Okay, well, hello. My name's James, as already been pointing out. I'm going to be talking today about building systems that are never done. So this talk is really about me thinking about all the practices I've learned over the years as a software engineer, as a developer, and whether they're applicable in the world of building microservices. That's really what this talk's about. Why is it called never done? Well, never done has a number of meanings, right? The first meaning of never done is something that's incomplete, right? So do I mean, when I talk about building systems that are never done, that we're building systems that are incomplete? Going back to that chaos report update from this morning, I don't want to be in that 50-odd% of developers who are building software that never works or never gets into production. So I don't really mean this. This is not what I mean by never done. Instead, I've been thinking about what it means to build systems that last, right? That stand the test of time. And for me, actually, this is where microservices started, where I started getting interested in this. It was in response to talking with quite a few people from different software communities, so the domain-driven design community, the sort of integration community, so people like Udi Dahan, people like Jimmy Nielsen, people in the sort of web integration community, so the REST community and the messaging community. And we sort of got together as a group, as a bunch of people, and sort of we were talking about systems and why systems are getting so big. Pretty much we spent 3 days trying to understand why we were all building products that we had to then replace after a couple of years. And for me, that was the key. It's like, what is it about these systems that means, or the applications that we build, the systems that we're building, that means they don't last more than 2 to 3 to 4 years. We have to throw them away. We have to go back to our management teams, our execs, and ask for another 10 million euros to rebuild something. So I'm trying to think of never done in the sense of building systems that last, that stand the test of time. So instead of this definition of them as being incomplete, I'm going to use this definition from a Terry Pratchett book, The Fifth Element. So Terry Pratchett is a British fantasy author. He passed away, sadly, a couple of months ago. But he's written over 40 books, one of which is The Fifth Elephant. And in this book, he describes a story. It's a dwarf with a big long beard and an axe, telling a story about his family's axe. And this is how I kind of think about building systems these days, about building systems that are never done. And he describes his family's axe, right? He says, this axe has been in my family for 900 years. This is my family's axe. And to paraphrase, of course, over time, every part of this axe has changed. We've replaced the handle, we've replaced the blade of the axe. Sometimes we've had to carve some new glyphs into the handle. Sometimes we've replaced the handle again. Sometimes we've replaced the head again. But is this not my family's axe 900 years later? And this is a retelling of a story, well, it's an ancient sort of philosophical thought experiment, the ship of Thebes. And the thought experiment there is it this, if you have a ship that lasts 300 years and every single piece of that ship has been replaced over those 300 years, at the end of the 300 years, when there's nothing left of the original ship, is it still the same ship? Terry Pratchett uses this in the My Family's Axe. And I think that's how we should be thinking about building systems. Chad Fowler, I saw him speak recently. He had a nice phrase. He said, or he had a nice idea. He said, we need to reclaim the word legacy, because legacy in IT has terribly bad connotations. Legacy is a bad thing. Legacy code is a bad thing. Legacy systems are bad things. And Chad was saying, well, what we need to do is actually look at legacy in a positive light, like Mozart or Bach left a legacy. They left a positive legacy. Like we want to leave a legacy to our children. We want to leave them something that's positive, not negative. And so this idea of reclaiming legacy, this idea of building systems that last, that span decent lengths of time, but composed of smaller systems, composed of microservices, that can be individually replaced. So that's what I mean by building software that's never done. Building software where the system as a whole lasts for a period of time, a long period of time, but the individual components of which can be changed or are changed over time. Fred, if you were here at the talk a minute ago, Fred was talking about one of the reasons we might want to use microservices, or the reason that people are talking about microservices. Adrian Cockcroft from Netflix are very clear on this. They want to use fine-grained service-oriented architectures because they want to go as fast as possible. We want to go faster for all the reasons we heard about earlier. So, our competitors, startups, taking our market share, needing to get inside our competitors' decision-making cycle to innovate faster than them. We need to be able to go as fast as possible. And in theory, microservices should allow us to do that, as well as being systems that last. They should allow us to make changes really, really quickly. And we heard examples earlier of an architectural, of an implementation of a microservice architecture, which allows you to do that. So this is what I kind of would hope for from a microservices-based architecture. They should be cheap to replace over time. They should be quick to scale. We should be able to bring stuff up and bring stuff down. And they should be robust, resilient, able to withstand failure. The old line, the internet is not a 5 nines fabric, has never been more appropriate. And they should allow us to go as fast as possible. I'm going to cover quickly some of the same ground that Fred did, not much of it though. So this is a quote from Neil Ford, answering the question, or attempting to answer the question, why now? And Neil's response to this question was, well, it's the first post-DevOps architectural style. It's the first attempt we've made as an industry post the DevOps movement, the DevOps culture developing, the build it, run it culture developing, to develop an architectural style, to develop systems differently. Dan North, who's another former colleague like Fred and many others who have been involved in this community, he's got a different take on microservices. In fact, he hates the name microservices. He thinks it's a terrible name. He prefers the much less snappy, in my opinion, but no less valid, replaceable component architecture. So that's what we're talking about with microservices, replaceable component architectures, systems that are never done, that can be changed over time. Dan North lost the naming battle. Turns out when Martin Fowler names something, it stays named. So sorry, Dan. And it's interesting because there's another theme running through Fred's talk was about how we're learning, how we're learning how to build these systems composed of smaller systems. And in some ways, the future's quite scary. And I'm just going to take a moment to explain what I mean by this future that we're living in, or the future that we're about to live in, or something, being a little scary. So this is a quote from some decades ago now. It's attributed to John von Neumann, a Polish mathematician called Stanislaw Ulam, who worked closely with Neumann. Recorded a conversation he had where Neumann talked about the concept of a singularity, a technological singularity based on the fact that computer hardware, for example, was getting faster. He says, ever accelerating progress and changes in the mode of human life gives the appearance of approaching some essential singularity in the history of the race beyond which human affairs as we know them could not continue. Now, I've seen a singularity with my own eyes, and it happened a couple of years ago. This is a panel at GOTO Aarhus. And it's interesting because at GOTO Aarhus that year, it was 2 years ago, I think, the feedback that was gotten from the people who were attending the conference was along a theme of why don't the speakers tell us what to do? There were lots of conference talks about about different technologies and about different techniques, things like microservices, but no one had any concrete answers really to give. And this is kind of this weird singularity where a lot of the most well-known people in our industry were kind of shrugging their shoulders a bit and saying, we don't really know what's going to happen at the moment. There's all these tools being developed. There's all these new practices, these new principles, these new styles. So one of these, I mean, you might recognize, this is from a few years ago, but it was probably last year that the JavaScript Singularity happened. You can't walk past a JavaScript developer without 3 new MVC libraries falling out of their pocket, right? JavaScript has just exploded. But also, similarly, containers have, well, hopefully not exploded, but the container technology and companies developing containers and different container based solutions are exploding. There's this kind of weird container singularity. And as mentioned earlier, I'm a part of the Thoughtworks Technology Advisory Board, and we've put together this tech radar, and we've noticed another one. And the other one we've noticed is to do with things like log aggregation. So log aggregation singularity. You can't talk to someone who in operations or a sort of a person in a DevOps role these days without them telling you like 15 different log aggregation frameworks. You should be using the Elk stack. No, we're going to be using Logstash and Kibana. No, you need to buy Splunk, to which the answer is, how much money have you got, right? Because Splunk will essentially suck all your money out of you, so you better be able to replace it quite quickly. But there's these different sort of singularities that we're sort of experiencing. And as well as that, there's this sort of microservice singularity occurring. So sort of closer to home for us, how we design software is definitely changing based on all these different tools being developed, the practices, the principles. And as I mentioned a minute ago, when Martin names something, it stays named. This is our attempt, Martin and my attempt to describe the characteristics of a microservice architectural style. So we were very clear here. We weren't trying to define what microservices are. We were trying to describe what we were seeing teams do in the wild. We talk about containerization by services and organized around business capabilities and so on. And that's great because teams are having lots and lots of success, right, with the microservices style. There are many, many software existence proofs of companies that are having success with this style. From the big, the Netflixes and the Twitters and the Googles and the eBays and the PayPals, etc., to the smaller ones, to the startups who are building out microservices-based architectures. But there are some really hard problems to solve with microservices. The first one I think is a really hard problem is how do you do end-to-end testing when you're building out microservice-based architectures? So this is something that we have gotten used to over a period of time in our industry, the ability to run essentially product-level tests where we test from the outside in, maybe using a browser or something, or maybe driving an API, and that's going to test all of our code, or at least test the happy path maybe of user journeys through our code base. This kind of automated end-to-end testing is really valuable for us to know whether our software is working or not. It gives us feedback as part of our build cycle, really, really useful. The next thing is, how do we deploy these things independently? How do we avoid having to deploy lots of small things in lockstep? Because the danger, of course, when you separate applications out into many small microservices is that you go from a monolithic big ball of mud full of spaghetti code to a distributed monolith, a distributed big ball of mud where everything is tightly coupled and you have to deploy everything together. We want to avoid doing things like deploying in lockstep. How do we do that? And the next thing is, we heard a little about this a minute ago, how do we do service versioning? How do we evolve these services independently? Given that we want to be deploying them on their own, given that it's difficult to test them end to end. And these are real problems, and we're learning how to solve them. I don't think if anyone tells you they've got the answer to this, that they're telling you the truth, if I'm honest. I'm also a consultant, by the way, so it depends is my default response to this. But how do we do this? Do we have approaches? And this led me to thinking about whether we have, whether we can still rely on some of the other tools in our toolbox. I'll talk about that in a moment. So what do I mean by testing microservices is hard? So we've got a couple of services here. This is a quick example. I'm using the test pyramid. So large test, medium, and small. Small, probably unit testing. Large are the kind of end-to-end tests, your product tests. I'm calling them large, not something like end-to-end, because it's a bit like the Vi Emacs battle, right? If you say end-to-end, someone else wants to call them user journey tests or acceptance tests or integration tests or whatever. So large tests, tests that execute and cover a lot of our application, a lot of our product. And in that sort of scenario, we're going to want to write a test which is going to drive one of our services, and it's going to need to integrate with another one of our services. So what's so hard about that? Well, suddenly we have to think about creating environments to deploy these things into, deploying lots of different things into. It's fine if you've got 2 maybe. What if you've got 1,000 different services? Can you write an end-to-end test that when you commit some code and code passes through your build pipeline, will be executed against the new service and 1,000 of its dependencies in some kind of test environment? How do you actually do that? That's quite tricky. And what we've sort of been talking about really over the last couple of years is not doing that. So actually always testing these things in isolation as part of, quote, end-to-end testing. So doing away in some ways with integration testing and integration environments. Instead using stubs, so stubbing out any external dependencies of a service. Another thing that's quite hard, and this is quite a subtle point, is not only the testing, the end-to-end testing of these services, the product-level testing of these services becoming difficult, but integrating these services, right? Building them independently. Services will pass through, or code will pass through a build pipeline in stages. This is generally what happens when we write software these days, and we're following continuous delivery practices. And that's fine when you've got a big application, because you have a build pipeline and it passes through it and then gets deployed potentially automatically into production. That's brilliant. It's been verified. It works. But suddenly, if you've got 10 build pipelines or 100 build pipelines, and all these services are talking with one another potentially, how do we make that work? Well, one way, the traditional way, would be to fan in and deploy these things into an integration environment. Right? We'll deploy them into some integration testing environment and run a set of integration tests against them, which is fine if you've got a very small number of things. But when, as I say, you end up with lots of these things, I'm having the same problem with the clicker as Fred did standing over there, so I'll move back. When you've got lots of these things, this becomes almost geometrically more complicated. Because what we're having to do when each one of these things changes is deploy into the integration environment, run some tests against them. But what happens with the race condition of me committing, or another team committing code to another one of the services, which passes through its own build pipeline? Does it go into the same integration environment? What happens if it overwrites a version that another pipeline is depending on? Oh, well, maybe we'll have to create another integration test environment where we'll have the integration test for each of the individual pipelines is based on its production dependencies, and then we'll push into that and run some integration tests against the production versions. But what happens about the deadlock, the race condition rather? Do we create another integration environment per build pipeline? So we suddenly have 2 with snapshot dependencies and all the production dependencies. Suddenly, it starts to get very complicated. If you've got 10 services, you're talking in using that approach, you've got 2 integration environments per build pipeline times the number of services. So that's, it's kind of complicated. So maybe these are examples of some of the practices that we've been following as part of, using XP, the XP practices and things that aren't necessarily longer that valid. And I'll talk about some approaches to addressing this later on. But as I say, I was thinking about then the other practices we've come to rely on. And I work for Thoughtworks, as has been mentioned, and whilst we're a agile small A shop, so we don't really say we're a Scrum shop or whatever. But the thing I think we probably all would agree on is that we're an extreme programming shop. We pair program pretty much on everything. We use test-driven development. We design our code through tests. We follow a load of the principles that you might expect from XP and from things like software craftsmanship, clean code, pragmatic programmer. So emergent design, gang of 4 design patterns. Keep it simple, stupid. The grasp patterns. These are all tools that have been in our toolkit for quite a long period of time, like things like integration testing, like things like integration environments. Are these still valid when we're building systems composed of small microservices? That's what I was thinking. I was chatting with a friend over in the States, a guy called Russ Olson, who's an awesome dude. He did a fantastic talk at QCon London, and it was called To the Moon, and it was about him remembering the Apollo moon landings and what we as engineers can take from the Apollo moon landings and the engineering that went into them. Fantastic keynote. I'd recommend looking it up, To the Moon. But Russ told me this other story about NASA and about the early stages of about manned space exploration. And he told me about this thing. This is part of the Gemini project. And with the Gemini project, they initially wanted to land it on a runway using a hang glider. Right? That might sound a bit strange, but if you think back, to the I guess early '60s, NASA was composed of a bunch of people who were essentially aeronautical engineers and pilots. That's what NASA was made up of. And when they were tasked with designing a spaceship that was going to essentially go into space, be launched into space, orbit the Earth, and then land back again as a test, essentially, for the Apollo program going to the moon, the aeronautical engineers and the pilots reverted to what they kind of knew best, and that was landing planes on runways. They were kind of in this very closed environment, and this kind of made sense to them based on their experiences. And then something funny happened, and that was a program manager came from externally to the group, and he took a look at their plans. And actually, this kind of did work, by the way. This did land. The Gemini capsule was able to go to space and land on using a hang glider. But this project manager kind of took a look at this, program manager took a look at this, and he said, well, he basically said, are you insane? He's sort of come in from outside, and he said, look, this is a crazy kind of approach to solving these problems. What you want to be doing, because it's much easier, much cheaper, and much safer for everyone involved, is to basically strap a couple of big parachutes on the top and drop it into the sea, and then we'll collect it. And that's what ended up happening. That's what ended up happening with Apollo as well. So I was thinking about this idea of someone externally coming in and looking at our practices and things, and also this idea of chunking up levels of abstraction. So we've got microservices, we've got all the practices we understand about how to write clean code, how to write well-designed, say, object-oriented code. What does that look like in the context of chunking up to the level of microservices and microservices-based architecture? So how to think about that, and that's what the rest of this is about. And what I thought was, essentially, it's turtles all the way down. It's turtles all the way from objects, functions, all the way up to systems of systems. And so I'm going to explain maybe my reasoning and maybe explain why some of the things we've come to rely on, in my opinion, after thinking a bit about this, are still valid. So the first thing I want to talk about, out of this big group of techniques, I won't cover them all. I might talk about World of Warcraft at the end if people really want me to. And the first thing I'm going to talk about is the Agony. So can I have a hands up in the room for people who have come across the Agony? You aren't going to need it, all right? This is a fairly common principle by which people, especially extreme programmers and agile developers, kind of approached the idea of writing code. I mean, for me, Agony is actually about test-driven development more than anything. So I learned about the Agony principle from a few colleagues, where if you're test driving your code, even a variable created that isn't needed by your tests is essentially the Agony. You aren't going to need it. Get rid of it. It's waste. And Martin Fowler has recently described this in an article, and he describes the four types of waste that you get with the Agony, right? So the important one from my example, that introducing an extra variable, even if you don't think that's like a big deal in your code, it actually increases the cost of carry of your code base. It increases the amount of stuff you have by definition. And over time, that stuff accrues. And unless you fix your broken windows, it'll accrue and accrue and accrue, and you end up with kind of messy, spaghetti-like code. I was thinking, does the Agony apply when we're building out microservices applications? I think it does. I think it definitely does. In the sense that what we want to be doing when we're building microservices is not building stuff out ahead of time that we don't need. And this might be obvious, but you'd be surprised at the number of ivory tower types who've moved into building microservices who say, right, what we're going to do now is design all of our microservices. Right, now go off and do it. In my opinion, that's not going to work. The approach I think we should still take is that you aren't going to need it. Build out things when you need it, when you need them, only when you need them. So initially build out one service. And then when you need to build out another one, maybe the code base is too complex, maybe for other factors, maybe non-functional factors, build out the next service. So I think this answer almost to the idea of, do we start with a monolith or not? But crucially, the Agony as applies to microservices architectures is all about building things out when you need them, not designing up front again. So for me, that kind of still holds. This is a set of patterns that seems to have fallen out of general, not use, because people still recognize the importance, but of people's collective memory. Hands up if you've come across GRASP. Yeah, it's kind of interesting. I mean, so this is, when I first started getting interested in sort of design, Gang of Four and all these things, I was introduced to GRASP, and it stands for the General Responsibility Assignment in Software Patterns. I'm pretty sure I got that right. And they were developed by a guy called Craig Larman, who became, I guess, more well-known later on for writing books about agile management techniques, agile software development and managing agile software projects. But from GRASP, we get a couple of really, really well-known and kind of obvious patterns that apply at the level of microservices. I'm going to illustrate this with an example. So I was at a client of ours last summer, and they were in an interesting place because they'd been building one set of services out in India and one set of services in the UK. They had a big team in India, a big team in the UK. And either by luck or by happy chance, each of these different locations were building out a particular capability, right? So in India, it was building one thing, a very discrete thing, and in London, they were building another discrete thing. They were kind of a travel company. They sell tickets for things. So one place was building the bit where you could buy tickets as a customer, and the other bit was building the bit where you got sent the tickets, right? Essentially retail fulfillment. There's other more complicated stuff in the middle as well, but that's pretty much it. Retail and fulfillment. And the really nice thing about this, and I think maybe the obvious thing that happened, and again, whether by luck or judgment or some other or something else, they'd ended up with this solution where they had a big thing in London and a big thing in India with a bus in the middle, and they were passing messages across between the two. Incidentally, Simon Brown, if you know him, hates my architecture diagrams. And this is an example, actually, of two patterns from GRASP. So GRASP talks about, in an ideal world, we want to have highly cohesive software and loosely coupled software. And these two independent capabilities were extremely loosely coupled by this bus in the middle and the message passing. It kind of worked out really, really well. The two teams could operate independently, deploy, test independently, and so on. So absolutely, I think when we're building microservices-based architectures, we want to be looking for high cohesion and low coupling. And I think historically we've done a bad job, especially at cohesion, because what we've tended to do is focus on cohesion around technical concerns. So we'll be cohesive about, we'll separate concerns and be cohesive about presentation and persistence, say. And so we'll put all the presentation stuff in one place and all the persistence stuff in another place, which is kind of cohesive around technical concerns. But that leads to kind of very tight coupling between business concerns. So in this example, what we're being is cohesive around the business concerns, the business capabilities, the actual kind of functional stuff that this thing has to do, rather than the technical organization of it. That's the next thing. The next thing I want to talk about is dry. So this came up as a question in the last, at the end of the last talk, from Fred's talk. So don't repeat yourself, dry. And this often comes up, should we allow duplication between services? Or should we maybe extract some common code, extract some common domain libraries, and so that we share code between services? So my simple answer is you shouldn't extract common code unless it's very, very basic infrastructure type code. I'll explain why. So this is the definition of dry. This is from Prague Dave, I believe, if he's in the room, I'm not sure. Every piece of knowledge must have a single, unambiguous, authoritative representation within a system. I was thinking, does this still hold true again for microservices? You've heard my answer already, but I'll explain my reasoning. So if we've got two services, and we've got some shared code indicated by the star in this diagram, or common, maybe duplication across these things. The temptation is to extract that star and say, do you know what? Reuse, we'll put it into some jar file somewhere or some shared DLL. We'll stick it in NuGet these days. We'll stick it in our Maven repo, in our Artifactory repository. And then, whatever needs it can pull it down. And they can include it at compile time, and then they can be deployed. It can be deployed. But the problem with this is anytime you introduce shared binary dependencies between different services, you completely lock their change cycles together. And if you've ever used WSDL binding for the WS Death Star kind of stack, if you've ever used WSDL binding, that's where you generate stubs at you generate stubs as a pre-processing step, and then include those stubs in your application, and use those stubs to make calls across the network. If you've ever used that, you've probably seen the problems with it, which is every time one of those APIs change, suddenly every single one of your clients is going to recompile and redeploy. Well, this is why we don't, or rather, myself and my colleagues at Thoughtworks don't tend to favor using something like WSDL binding, but extracting shared domain code gives you exactly the same problem. Suddenly you're locking your change cycles of your software together. And if you've got hundreds of microservices, and maybe they all share something common called a customer, you really don't want to have to be redeploying 100 things every time your customer gets a new field. It kind of sucks. There are different approaches to addressing this, right? I mentioned that, for example, I'm personally okay with extracting out things like shared infrastructure code. If you've got a HTTP client, that's probably okay to put into a NuGet package somewhere or into a jar file. Right? If you look at all the Netflix open source tooling, that's all very specifically generic. It's things like circuit breaker implementation, bulkhead implementations, monitoring, these sorts of things. I'm fine with that. There's another approach, which is to use something called a service template. So a lot of the tooling now, so things like Spring Boot or Drop Wizard, go some way towards providing a template you can use to build out services. And there are others in other languages, but those are the ones I'm most familiar with. But what they don't do is give you the domain-specific stuff that you require in your organization on top. So good practice we found is to extract a service template which contains maybe the way we do logging here, the way we do monitoring, the way we do status pages. Put that in a shared location, and then when you need to create a new service, you can just clone it as in Git, for example. So service templates. And the reason, another one of the reasons that this is a good idea is because essentially, if we're not sharing domain code, or even if we are sharing domain code, each of our services over time is going to change, is going to go through its own set of individual changes. They're going to diverge from your service template, essentially. They're going to go through different trousers of bifurcated trousers of reality. And so this is why, essentially, I've come to this conclusion, which is the same one that Fred had, which is essentially copy and paste is okay, right? Copy and paste is fine. But I still think we should be dry within services. So within the individual microservices, I think we should still apply the same sort of practices to remove duplication. So keep the code clean. Next up. So there's been quite a lot of controversy about test-driven development recently. Should we do it? Should we do it at all? Is it just waste? Is it just waste? I have my own opinions on this. And they don't always correspond with some of our other well-known people in our industry. So test-driven development, I've been using test-driven development as a tool for design primarily for, I'm not entirely sure, I don't know, certainly over a decade. And I was very lucky because I actually learned how to write code guided by tests by a bunch of people I worked with at Thoughtworks when I joined about 10 years ago, 11 years ago. And as part of learning how to write code guided by tests, I noticed a really funny thing, which was the code I wrote ended up looking a certain way. People have noticed this. If you follow the test, write a test, write some code, refactor, red, green, refactor cycle. But your code ends up looking a certain way in object-oriented languages. You end up with small objects, generally, with small numbers of responsibilities. You tend to inject things through constructors, dependencies through constructors. Code looks simple and understandable. And over time, sometimes I don't use test-driven development exclusively. I'm going to be honest. Sometimes I just think, actually, do you know what? I understand this problem well enough. I'll have a test around the outside that verifies that my software is working, or that these units of software are working, and then I'll carry on writing some code. But in general, over the last 10, 11 years, whatever it is, the way I write code has been guided by learning how to do TDD. Why do I think then test-driven development, apart from the fact that I think it drives clean code, why do I think that this is important for microservices? Well, we already talked a minute ago at the beginning about how end-to-end testing becomes really, really hard. Right? So writing lots of these large tests becomes really, really difficult. Actually, writing more unit tests then, isolating these services and writing unit tests for the functionality within them, for the code within them, becomes more important in that case. If you haven't read this book, it's a fantastic book. Mike Feathers describes growing object-oriented software guided by tests by Nat Price and Steve Freeman as the London School of Test-Driven Development. Both of the authors were at Thoughtworks London when I joined. I spent some time, met them obviously, and spent some time with them. Never actually worked on a project with them. But this book describes how Thoughtworks London, or the people working within Thoughtworks London, really think about writing test-driven code and how to design your software by writing tests first. So, in order to answer this question, or maybe a slightly different question, should we bother with test driving our code if we're just going to throw things away, right? We're building replaceable microservices that we can throw away, building software that's never done. Should we bother with it? In my opinion, I think we should, because the value I personally get, and I see our teams getting from writing tests, especially unit tests, and test driving their code, and the importance of having more smaller tests with microservices, for me, mean I believe we should be. And I'm just going to maybe cover off some of the controversies. These are some of the people I was fortunate enough to work with in Thoughtworks London. So a lot of these people have become fairly well known, either in the testing community, the design community, the architecture communities. So for example, Nat Price and Steve Freeman wrote that book down north, originator of BDD. Liz Keogh, she's got a Pask Award from the Agilist, a bunch of others. And over time, their opinions about TDD have changed. And over time, a lot of well-known figures in our industry's opinions about TDD have changed. My feeling, as I said, is that test driving our code is still very, very valuable. And I'd like to maybe clarify the way I think about how maybe some other people talk about TDD. This is something called the Dreyfus model of skill acquisition. Now, I've been in software for, I don't know, whatever it is, 15 years, 16 years. I'm not quite a greybeard, because that's 20 years, but I do have a greybeard, if that helps. So I've been writing software for a little while, and in some areas of software development, I'd consider myself an expert on the Dreyfus scale. Right. Proficient or an expert. Probably proficient or expert in test-driven development, anyway. And a lot of the people who I just mentioned are also experts in test-driven development. They've learned the lessons, and they're starting to move on. They've internalized what they've learned around how to write code guided by tests. I guess the reason I'm mentioning this is think carefully before taking the advice that with microservices, suddenly we shouldn't write any, we shouldn't test drive our code anymore. Because a lot of the people giving advice, although valid advice for them and for the work they do, they're coming from a position of expertise, having learned the lessons. They already write code in a certain way because they've learned how to do that through writing code test first. So, to summarize, should we write unit tests? Personally, I think we should. And I think it's more important than ever. We need to keep to that test pyramid with lots of small tests at the bottom. The next thing is SRP, single responsibility principle. An object should have a single reason to change, was the original statement. So my colleague, who's now at former colleague who's now at Neo4j, Alistair Jones, him and myself were on a team, and we came up with this heuristic. Essentially, it's a restatement of SRP, and it's a class should be no bigger than my head. And this is Alistair's head. This is in Neo, actually, at Neo, in their offices in London. So this is Alistair's head, and he's checking whether a class is big enough, or too big, rather. And I think on the tweet, they decided it was fine. But what do we mean by no bigger than our head, and how does that apply to microservices? Well, for me, I said it's turtles all the way up, and I think it is. As you chunk up different levels of abstraction, for me, the single responsibility principle applies. The other way of looking at the no bigger than my head thing is I should be able to understand everything about an object. Right? I should be able to I should be able to reason about exactly what an object is doing. It should have a single responsibility, single reason to change. And as you chunk up from the level of an object into, say, a service, that should have a single responsibility. And as you chunk up again to the level of maybe a set of services that a team owns, that should have a single responsibility, single reason to change. As you chunk up again to the level of a system of systems, single responsibility. And at each level of abstraction, you should be able to fit this stuff into your head. Obviously, I can't hold my head up to a monitor and check whether Netflix fits, the entire distributed architecture of Netflix is as big as my head. But conceptually, that's the case. So SRP, a service should be no bigger than my head. The next one, KISS. Hands up. KISS, keep it simple, stupid. Or keep it simple if we're being nice. So this is something from the last edition of our technology radar at Thoughtworks, and this is where we put application servers on hold. Now this is a bit scary to many people, a bit scary to ops teams, but we were just trying to call out essentially that times have changed. We no longer need to use big iron application servers. We no longer need to deploy microservices, lots of them, into a big application server. I'm afraid for those people who are currently on the WebLogic team. It's not looking so great. And the interesting thing is, it's because if you think about it, well, times have changed, right? We've gone from having one expensive big machine so that we would put an application server which would manage lots and lots of applications on it, to having lots and lots of small machines. Right? This is the movement towards or the container movement, or a single service per machine image, a single service per instance on a infrastructure as a service. We don't need the heavyweight application servers in that world. They just get in the way of testing. They slow testing down. They make continuous delivery harder. They make my job as a developer, again, trying to get code out fast, harder. Application servers on hold. When I think about KISS, this goes through my head, WWJD. And that probably doesn't make sense, but it means, what would Joe do? So this is Joe Warnes, who I worked with for a time in Thoughtworks, and he is by far the most productive developer I've ever met. I'm not a big fan of the kind of 10 times productivity thing, but Joe on his own is about equivalent to a team of about 10 people, so maybe there's some truth in it. And when I think about what Joe would do is the simplest possible thing. He would keep things really, really simple. If he's faced with a problem, he solves it in a very, very elegant, simple way. An example of that is, he was on a project and he needed to communicate via WebSockets with a client browser. And he was looking around at all the different WebSocket support and the different app servers out there. And he's looking at these kind of big things. He thought, nah, I'm not going to do that. And so what he did instead is he wrote his own. He wrote his own application server. Now that sounds crazy, right? It sounds crazy that we might go out and write our own application server. But actually, sometimes doing things like that is the simplest thing that can possibly work. Keeping it simple. And I'm going to give you another example of this from a project I was on. So we were building out microservice architectures for a science publishing site, and we had the requirement to try and visualize our infrastructure. We were deploying into AWS, and we wanted to visualize our infrastructure. So we had a couple of options, one of which was to wait until some of the heavy tool providers were able to support immutable servers and kind of append-only infrastructure. This is where servers are going away up and down all the time, and lots of the big software houses don't support that sort of style yet. We could deploy something like Console, but in order to production harden Console, you're talking about 5-node rings, and it's quite complicated to get that. And in the meantime, until we got there, we didn't really understand what was running in production. And so 2 days, me and a mate came up with this visualization. So this is our production infrastructure doing a blue-green deploy, if you can see that. And we used cron and Python and Botto and PyDot and GraphViz. And this worked, right? This was the simplest thing that we could do to visualize our infrastructure such that our testers understood what versions were running, that developers could look at a screen and see, right, okay, the DNS endpoint has switched over. The simplest thing that could possibly work. And then eventually we put Console in and we've got all the nice dashboards and things. So does keep it simple mean much in this sense? I think it still applies. I think it still applies in the sense it's always applied, which is try and find the simplest solution that we possibly can. Don't lean towards very big, heavyweight solutions. Do the simplest thing possible. So, quickly, because I've got 2 minutes left, I'm going to talk about integration and deployment. So I covered those off at the start. So if we are in this world where integration testing, all these other practices are kind of still valid, what about this kind of integration testing, integration environments problem that don't seem to be valid? Are there other tools we can put into our toolbox? Well, I think there are. So the first thing we can add in is this idea of semantic monitoring. So semantic monitoring is where, in production, we run things that would be normally things like user journey tests or acceptance tests against our production infrastructure. So we do testing, if you like, in production. This is not so different from the idea of smoke testing. It's just slightly more, it's a slightly more disciplined approach. There's a big description of it on the Thoughtworks radar site, so have a look. That's the first thing. The next thing I think we can do, and I think there'll be some talking about this later, is we can try and get feedback for when we break things earlier. Animation's broken. Earlier in our feedback cycles. So we can deploy our software into production and see if it breaks. That's one approach, and semantic monitoring will tell us if it does. But another thing we might want to do as developers is understand a bit earlier. And so we can write executable contracts for our services and give them to the people who write the services, and these are called consumer-driven contracts. And these can be executed as part of our build cycle. So we write consumer-driven contracts, hand them over to the providers of services, and then when they run their build, if behavior has changed, the build breaks. Sorry to get a bit meta. I'm going to deliberately run over time by a couple of minutes. The reason being we don't want to completely flood the lunch queues. I was asked to do that. Anyway, back to consumer-driven contracts. It's quite simply what you do is you write a set of expectations as a consumer of a service. Right? It's an executable format, and you include it as part of the services build pipeline. Simple idea, but actually it was revolutionary 10 years ago. It hasn't really been adopted until maybe this year, last year, and now there's tooling available to do this, certainly in Ruby, so this is Pact, which is available on GitHub as an open source tool. So the next thing is testing in production. I mentioned it briefly. What do I mean by testing in production? Well, rather than QAing as part of a formal UAT stage before we deploy our software or fanning into an integration environment, we actually push our software straight into production and test there. Right? If we've got really good monitoring so we know things aren't going to break, this is a kind of valid approach. If we've got semantic monitoring, if we've got consumer-driven contracts in place so that we minimize the number of breaking changes that get there, this is going to work. So what this relies on, though, of course, is being able to say our QAs, our product managers, our product owners are able to log in and, we are able to distinguish who they are so that they can test in production. So am I really saying we're going to do away with integration environments? I think a lot of companies who are building microservice architectures already have. I think as you get more of these things, I think it's inevitable. I think that's just the way you have to go. That's scary. I'm sorry. Just the way it is. But this is something that maybe helps deal with the pain. And this is a realization I had. Again, it's going back to what we did. We'd have maybe 2 data centers, and we'd have an active and a passive. We'd have some software running in one, and then we'd upgrade the other one. One was live, and one was not. These days, with elastic infrastructure, when we're deploying things into infrastructure as a service providers, there is a difference between deploying into your production environment, so standing something up that's out there, that's on the web, and it actually being used by people. There's a difference between being live, getting live traffic, and actually being in production. So you can actually deploy as many versions of things as you want into your elastic infrastructure, but unless actually users are using it, it's not live. So this makes the idea of doing away with integration environments a bit less scary, right? Because we can just deploy into production. We can allow our product owners, product managers, business folk, QAs to test things in production. And then we can make it live by directing traffic. And this is, ways of doing this include, this is kind of canary builds, blue-green deploys, and it's related to A/B testing. So, finally, changing services independently. And this is something I sort of learned from talking with a few people, Adrian Cockcroft in particular. If we're going to make a change to a service, commit some code, it's going to go through into production. One of the things we have to think about is what is the blast radius of that change, right? Who is that change going to impact? What other services will that change impact? And I think there's almost like 3 levels here. The first level is whether the change is limited within your team, whether anyone outside of your team is going to be affected. Because if it's not going to expand the blast radius, the blast isn't going to expand past your team, then probably you can handle versioning and change just by talking to people. I'm going to change this. you have to change your thing now. Is that okay? Yeah, fine. Off we go. The next thing is it limited within a bounded context? Oh, sorry, between bounded contexts. And if it is, then you might want to think about consumer-driven contracts and maybe semantic versioning, these sorts of techniques. And the third thing is organizational. So if you're Google, you don't want to be changing the Maps API very often because the blast radius of that is, well, it's kind of Western civilization as we know it, right? And the reason I was thinking about this is this book by Thomas Allen. He talks about how information flows around in organizations. And it's interesting because after about 15 meters or 10 meters away from someone, the probability of interacting, of having serendipitous conversations, is practically zero. Why is this important? Well, you want to limit the change. You want to apply different techniques the further away you are from someone. And this is, again, where Conway's law kicks in. So for intercompany integration, maybe you're thinking about patterns like semantic versioning. But when you're talking about change within an organization, between teams, say, you're applying different types of things. So semantic versioning, maybe contract testing, tolerant readers. And then within teams, maybe we're talking about conversational change. So I change this, can you change your thing? To sum up, the future's scary, right? We don't know how to do a lot of this stuff yet, to paraphrase, or to reiterate what Fred was saying. But at the same time, a lot of the stuff we know how to do already still applies, I think, when we're building microservices, so that's kind of a cool thing. And also, there's a load of new cool stuff that we can do. Right? And there's a lot of new stuff to learn, and frankly, one of the reasons I'm in software is because I love learning new stuff. So, in summary, do the simplest possible thing. Thanks very much. And I don't...